Studies Section 13. Correlation Analysis. Introduction. This lecture examines the measure of association between two variables at the interval level of measurement. It begins by explaining the use of scatter diagram and the various forms of association between two variables. The product moment correlation coefficient and the Spearman rank correlation are also fully examined. Objectives. After studying this lecture, you should be able to 1. Illustrate the use of scatter diagram. 2. Calculate the coefficient of correlation R. 3. Interpret the value of the correlation coefficient R. Pretest. 1. The main property of the correlation coefficient R is that it lies between A, 0 and 1, B, 0 and minus 1, C, minus 1 and plus 1, D, minus 1 and 0. 2. What is the value of R when there is a perfect inverse relationship between two variables? A, minus 1, B, plus 1, C, 0, D, 2. 3. Pearson's R considers rank of the score, while Spearman's R considers the raw scores. Yes or no? 4. The basic assumption of Pearson's R is based on linearity between the variables. Yes or no? 5. The straight line that passes through most of the scattered points is known as A. Line of best fit, B. Line of curvature, C. Line of correlation, D. None of the above. Content. Section 1. Measure of association. Correlation measures the degree of association between variables. The coefficient of correlation is a single number that tells us to what extent two variables or things are related and to what extent variations in one variable go with variations in the others. Agarwal, YP 1998, page 120. The scatter diagram. If we have data on two variables measured on the interval or ratio scale and we are interested in examining the relationship between them, we can plot the data by putting the dependent variables on the vertical axis and the independent variables on the horizontal axis. The resulting plot is what we call the scatter diagram. It gives a clear picture of the direction of the relationship between the two variables. There are three main forms of association between two variables. 1. Positive correlation or direct association. Dependent against independent, that is R is equal to positive. 2. Negative correlation or inverse association, dependent against independent, that is R is negative. 3. Zero correlation or uncorrelated, dependent against independent, that is R is equal to 0. Product moment correlation coefficient, Pearson's. The product moment correlation coefficient, otherwise known as the Pearson moment correlation coefficient between x and y, is given by R is equal to n summation xy minus summation x in bracket, summation y in bracket, over square root of n summation x squared minus summation x in bracket squared n summation y squared minus summation y in bracket squared. The Pearson's R is based on the linearity assumption between the variables x and y. For the computation of R, use the table format below: x, y, x squared, y squared, xy, summation x, summation y, summation x squared, summation y squared, summation xy. Let us illustrate the use of this table with an example. Example 10.1. Given the data below, calculate the Pearson's correlation coefficient R between x and y and interpret your results. X 1, 3, 4, 6, 8, 9, 11, 14. Y 1, 2, 4, 4, 5, 7, 8, 9. Solution. Although the question does not ask you to plot scatter diagram, but you may plot it to have a rough idea of what the relationship is. Step 1. Scatter plot of x against y. From the scatter plot, it is clear that a positive relationship exists between x and y. Step 2. Arrange your data in the table format given above. X 1, 3, 4, 6, 8, 9, 11, 14. Summation x is equal to 56. Y 1, 2, 4, 4, 5, 7, 8, 9. Summation y is equal to 40. X squared 1, 9, 16, 36, 64, 81, 121, 196. Summation x squared is equal to 524. Y squared 1, 4, 16, 16, 25, 49, 64, 81. Summation y squared is equal to 256. XY 1, 6, 16, 24, 40, 63, 88, 126. Summation xy is equal to 364. Note that adding together values in column x gives summation x is equal to 56. Y gives summation y equal to 40. X squared gives summation x squared is equal to 524. Y squared gives summation y squared is equal to 256. XY gives summation xy is equal to 364. Also note that n is equal to 8 because there are 8 observations. Step 3. Now apply the formula 10.1 to calculate R. R is equal to n summation xy minus summation x in bracket, summation y in bracket, over square root of n summation x squared minus summation x in bracket squared, bracket n summation y squared minus summation y in bracket squared is equal to 8 times 364 minus 56 times 40 over 8 times 524 minus 56 squared in bracket 8 times 256 in bracket minus 40 in bracket squared is equal to 2912 minus 2240 over square root of 4192 minus 3136 in bracket 2048 minus 1600 in bracket is equal to 672 over square root of 1056 in bracket 448 in bracket is equal to 672 over square root of 473088 is equal to 672 over 687.8 is equal to 0.977 is equal to 0.97. Comment: the value of the correlation coefficient is very large. This shows that there is a very high linear correlation between x and y. An increase in one of the variables is accompanied by a proportional increase in the other. Section 2. Spearman's rank correlation coefficient. Suppose the values of variables x and y are measured on a continuous scale and that they are jointly and normally distributed. Instead of using the precise value of the variables, we can rank the data in order of size, importance, preference, etc. Using the number 1, 2 to n, we then calculate the correlation coefficient as follows. Rs is equal to rho is equal to 1 minus 6 summation d squared over capital N into bracket n squared minus 1 bracket closed, equation 13.2, where d is equal to difference between ranks of corresponding values of x and y. N is equal to number of pairs of value x, y in brackets. Where d is equal to difference between ranks of corresponding values of x and y. N is equal to number of pairs of value x, y in brackets. Example 10.2. Two different lecturers graded the exam script of 8 students. The marks recorded are as follows. Candidates: A, B, C, D, E, F, G, H. Scores awarded by lecture 1. Two different lecturers graded the exam script of 8 students. The marks recorded are as follows. Candidates: A, B, C, D, E, F, G, H. Scores awarded by lecturer 1: 46, 37, 71, 64, 48, 55, 35, 36. Scores awarded by lecturer 2: 48, 42, 68, 63, 60, 58, 41, 40. A. Calculate the rank correlation coefficient. B. What conclusion can you draw? Solution. Step 1. Rank the two scores using R1 for rank of scores awarded by lecturer 1 and R2 for scores awarded by lecturer 2. Note: the highest score is marked 8 and lowest is ranked 1. A, B, C, D, E, F, G, H. Lecturer 1: 46, 37, 71, 64, 48, 55, 35, 36. Lecturer 2: 48, 42, 68, 63, 50, 58, 41, 40. R1: 4, 3, 8, 7, 5, 6, 1, 2. R2: 4, 3, 8, 7, 5, 6, 2, 1. D is equal to R1 minus R2. 0, 0, 0, 0, 0, 0, minus 1, 1. D squared is equal to R1 minus R2 bracket squared. 0, 0, 0, 0, 0, 0, 1, 1. Summation D squared is equal to summation R1 minus R2 in bracket squared is equal to 1 plus 1 is equal to 2. Step 2. Apply the formula for calculating R. Spearman's rank is equal to 1 minus 6 summation d squared over capital N n squared minus 1 in brackets is equal to 1 minus 6 times 2 over 8 into bracket 8 squared minus 1 bracket closed is equal to 1 minus 12 over 8 into bracket 63 is equal to 1 minus 12 over 504 is equal to 504 minus 12 over 504 is equal to 492 over 504 is equal to 0.9902. The rank correlation coefficient is very high and positive. This shows that there is a very close tie between the marks awarded by the two lecturers. Summary. What we have just discussed is the correlation analysis, which measures the level of relationship between two variables. The person's product moment correlation coefficient considers the raw data recorded on an interval or ratio scale. The Spearman's rank correlation coefficient considers the rank of the score instead of the raw data. The scattered diagram is the graphical representation of the relationship between two variables. The line of best fit is the single line that passes through most of the scatter points. This is the end of Studies Section 13. Thanks for listening.